Hello, welcome back. So now in this part, we will solve another example for the truss. So again, we have to find out force in each member for this truss. So in this case, you can see there is a support in the form of roller, or we can say it as rocker. One support is there and the other support is there. So we have to find out force in each member, like member AB, AD, member BD and BC. So we have to find out force in all of these members. So now we will solve it. So before the solution, we will make the free body diagram. Now in the free body diagram, uh, we will show the probable direction of the reaction force. So in this diagram, you can see there are some probable direction of the reaction force here. So one reaction, as this is a roller, so this will offer only one reaction, which we are naming as AY. And then the second, on the second reaction, there will be two reactions actually, because this is hinged support. So two reaction, one will be horizontal and the second one will be vertical. So the direction of the reaction is arbitrary and we will solve the equation to calculate the value of these reactions. So if our values are positive, then we will say that the arbitrary assume these directions are correct. If any of the value is negative, then we have to change the sense of that particular reaction. So in this diagram, you can see none of the joint can be taken because all the joints are having more than two unknown members. Like if we consider joint A, in that case, two members are unknown, but at the same time, there is third reaction force is also unknown. Similarly, D joint cannot be taken. C joint cannot be taken. B joint cannot be taken. So that is why our first step is to find out the reactions. So we will apply the equations of equilibrium. We will apply summation of fx, summation of fy, and summation of m. So first we will apply summation of fx. So in while applying this equation, we will see how many horizontal forces are there and we will find out their summation. So you can see there are two horizontal force. One is the reaction and the second one is the external load, which is of 600 Newton. So this load is positive and this reaction sense is negative. So only two horizontal forces are there. So Cx, or reaction at C in x direction, is 600 Newton, which means the sense that we have assumed, it is correct because the value is positive. Similarly, then we will solve, we will use another equation. Say if we use a moment equation, so in that case we can take moment about any point, but generally we take moment about any of the reaction points. So either we take moment about A or about C, we will be able to identify, or we will be find out the one of the reaction. So we are taking moment about C. So this is the calculation. So first, this is AY. So AY will create positive moment about point C. Sorry, this is taken wrong. So this will be positive moment. So it will be AY into 6. Then the second force is 400 Newton. So the moment of 400 Newton about point C, it will be anti-clockwise. So it will be negative. So in the equation, please correct it. This value is positive, this value is negative, and then moment about, I mean moment of this force about C, so it will be again anti-clockwise, so we will take this as negative. So after solving this, we will get the value of AY as 600 Newton. So it means the direction that we have assumed, which is upward, it is correct because the value is positive. Then we will use another equation, which we have as summation of Fy equals to 0. So in this, we will find out the algebraic sum of all the vertical forces, which is uh, 600. So this ay is 600 and it is upward, so we have taken this as positive. Similarly, the second vertical force is 400 newton and the direction is downward, so we have taken this as negative. And also we have assumed the arbitrary sense of reaction, cy. So we have assumed this as downward, so we have taken this as negative. And now we will calculate the value of Cy, and Cy value is 200 Newton. And you can see the value of Cy is positive, which means the reaction is correct. The sense of this reaction is correct, which is downward. So now we have calculated the reactions. Now we will proceed to find out the force in each member. So now we can take any of the joint. Either we take joint A, B, C, and D. So either we take joint A or C. So there the choice is arbitrary. So we will take joint A, and the free body diagram of joint A is here. So as you can see, the angle is not given, but we can find out the slope of this member. Like you can see, this is 4 meter and this is 3 meter. So these are 4 units, this is 3 units. Then the slope will be, I mean the third side of this triangle will be 5. So with this we can find out the slope, and we can find out the horizontal and vertical component based on the slope. So summation of fx, first of all we will apply summation of fx. So this is FAD, it will be positive, and horizontal component of FAB, it will be negative. So FAB value can be calculated with this equation, which is FAB 750, and which is compression. So here you can see the sense that we have assumed as point A. So in this case, we have assumed that member AB is in compression because the arrow is pointing towards A, which means we have assumed that the member will be in compression. Then in member AD, we are assuming that it will be in tension and reaction is upward. The value is already known. So FAB value is 750 Newton, which is compression. So we have assumed the same sense, which is pointing towards the center, and it is compression. Then we will use the second equation, which is summation of Fy equals to 0. So vertical component of FAB will be negative and this value is positive. So with this we can find out the value of FAD, which is 450 Newton, and it will be in tension. So the sense that we have assumed in this joint, it is correct. It is tension because the value is positive. Then we can take, so just now we have uh, this is A, B, C, and D. So just now we have find out, we have analyzed this joint. Yes, so we have just analyzed the joint A. Now we will analyze, say, joint D. So in the joint D, we have now found the force in this member, and unknown members are this DC and BD. Okay, so we can take joint D and we will make the free body diagram of joint D. So now again we will simply apply the equation summation of Fx and write the equation. So this is the force that we have calculated in the previous slide, and this is FDB. horizontal component of FDB will be positive. So again here we have assumed that force in member BD will be in compression, and force in member DC, it will be in compression. So again I am saying that this sense, it is arbitrarily assumed. If you want to take sense opposite to this, you can take that and solve the equation. And if your answer is negative, then it means your sense is incorrect. You have to reverse it. Or if the value is positive, then your assumption is correct. So that is completely based on that. So we have just assumed that this member will be in compression and this member will be in tension. So based on that, the equation is there. So with this, FDB is minus 250 Newton. So there you can see the value of FDB is negative. What does it means? It means that the assumption that we have done, we have assumed here, we assume that member BD will be in compression, and because of that we have marked, I mean we have provided the sense of this arrow as pointing towards the joint. So this negative means force is not in, I mean this member is not under compression, but it is actually in tension. So that is what I have written. The negative sign indicates that FDB acts in the opposite sense. So FDB that we have assumed as compression, it is actually in tension. Okay. So we can correct it. We can correct in it later. So now to calculate the value of FDC, to calculate the value of FDC, now we have two options. Either we change the whole free body diagram with the correct sense which we found now, or we do the same calculation by putting the value of FDB as negative. So this is what I have written here. See here, to determine the value of FDC, we can either correct the sense of FDB on the free body diagram and then apply summation of Fy, or apply this equation retaining the negative sign for FDB. So we are doing this just to calculate the value of FDC. So either we correct the diagram and change the sense, which is the correct one, or what we can do is we will follow the same diagram, but to calculate the value of FDC, we put the value of FDB as negative. Then we will be able to identify, or we will be able to find out the value of FDC. So this is what I have written here. So we are retaining the same diagram. So we will now apply the equation summation of Fy and writing the equation. So there you can see FDC sense is again pointing towards the D. So it is negative, and the value of FDB, I am again retaining the previous sense, which is, I mean the vertical component of this will be negative. So there you can see the negative value we are retaining here in the equation just here, although it is in tension, but for the sake of calculation of this value, we are retaining the same sign. And after this, when we solve it, we find the value of FDC as 200 Newton. And this value is positive, which means the sense that we have assumed in member DC is correct. And it is in tension. Similarly, now the joint which is left here, I mean, now we have found the force in this member, this member, this member, and this member. So only member which is left here, it is member actually BC. So member BC is left. So for that, we will take joint C and make the free body diagram. So in the free body diagram, we know the reaction, we know the value of both the value of reaction, and then force in member DC, which is we have calculated in the previous slide, and unknown force which is there, it is the FCB. And we have assumed that force in member BC will be in compression. And because of that, you can see the arrow is pointing towards the joint C. So again, we are assuming this. If we get the positive value, our assumption will be correct. If we get the negative value, it means our assumption is incorrect and we have to reverse the sign. So summation of fx here. So summation of fx here, we can see here, FCB will be taken as positive and this value will be taken as negative. So FCB value is positive, which is 600 Newton. So it means the sense that we have assumed for member CB, it is correct and it is in the compression. Now we have found all the forces in all the member. So for a check, what we can do is we can apply the second equation, and if we get the zero answer, then we say that forces in all the members are, that we have calculated are correct. So if we apply equation this one, so in that case you can see this force and this force both are equal and opposite, and that is why we got the answer 0. And this worked as a check, which means we have calculated member member force in all the member, it is correct. Now in the last we have to show all the members with their true nature, whether these members are in compression or in tension. So we will make the detailed diagram which will be showing the member nature. So this member is in compression, so that is what I have shown here, and the magnitude is also there. Similarly, for this member, it was in tension, this was in tension, this was in compression, and this was in compression also. So this is how we have to make the final diagram, which will be showing the nature and magnitude of the member force. So that was the solution of example 3. So in the next lecture, we will solve these trusses using the second method, which is method of section. Thank you.